Welcome back again of CCNP 2.0 switch. I'm Aditya and this is video number 8. What we're going to look in this video, VTP version 1 and 2, their details, their modes in authentication. VTP pruning that we can perform using automatic pruning or a manual pruning. There is little bit different, we will discuss on it. VTP version 1, 2 drawback or a problem. That's why Cisco invented VTP version 3. So first let's enforce or recall your concept that we have discussed in CCNA. VTP stand for Vlan trunking protocol that reduce administration in switched network. While you have a switch, a center point of location, you can create and modify Vlan database. So yes, this is used to synchronize Vlan database whenever you create any Vlan or modify the Vlan. But make sure this is not going to assign any port to particular Vlan. For this you need to go to every switch and hop over switch by switch to assign the ports. Either you can use VMPS server so that you can automatically assign port to particular Vlan based on the MAC address. Since VTP is Cisco proprietary, so you need to take care that if you are going to connect some other box that is not part of Cisco. So obviously a trunk port has ability to send and receive VTP advertisement no matter your switch is operating as a server, client or transparent. So this is true about VTP version 1 and 2. There is little bit different in VTP version 3. That's why I am decided to make this separate video or dedicated video for VTP version 3. And we need to configure VTP domain name. So by default, a brand new switch, there is no VTP domain name, by default is null. So you need to configure VTP domain name and appropriate link that goes to particular switches or maybe a router. So by default VTP version 1 is enabled. Whenever you feel to enable VTP version 1 or 3, you need to execute command. Basically VTP version 1 and 2 has basic different. VTP version 1 not supporting token ring, where VTP version 2 support both of the technology. VTP version 1 and 2 not able to advertise extended and private Vlan, that was the drawback. In VTP domain, no one device can disable their VTP. So once you have VTP enable on your domain, you're going to join, and whatever trunk port belong to you, you are going to send and receive those messages to rest of other trunk port. So obviously in VTP we have VTP version 1 and 2, we have 3 mode of operation to particular switches: server, client and transparent, where server creation and modification allowed, and once you create anything or changes anything, that going to propagate to entire VTP domain. But by default all switches operate in VTP server mode. So we need to take care of this, and can we synchronize other server update on same VTP domain if configuration reversion number is higher than your current configuration reversion of server. Client, they cannot create or modified Vlan database, but they can assign port to particular Vlan. And they are totally dependent on server. Until and unless servers send any update to them, they are not going to do anything. So if you have a multiple server, so they going to comparison which one is the higher configuration reversion number to apply to their database. Transparent switches, they create modified Vlan, but those modification and creation locally only. They are not going to send their own Vlan database out of trunk port to other switches. They doesn't synchronize if they get any update from the server, but Since if a transparent switch has trunk port connected out of some other switches, they are going to advertise those messages. If server or client changes as a transparent, so they keep the previous VLAN. What I mean to say about this, or just let me explain. If you have a switch working as a server and you created VLAN 2, VLAN 3 and VLAN 4. Later you decide, let's convert this switch work as a transparent mode. That doesn't mean you're going to delete these VLAN that will be exist. But yes, your configuration reversion number going to revert as a 0. So sometime you may require to change your configuration reversion number as a 0. You can just convert your switch as a transparent and then after client or server. What do you like to do? Why so you require that? If this is your production network, this is two switches connected back to back to each other, and you may have a VLAN 2, VLAN 3 and VLAN 4 on both of switches, VLAN 2, VLAN 3 and VLAN 4. It might be configuration reversion number is 10, and you have a new switch that has configuration reversion number 20, and you decide change or delete all those VLAN that is already exist in this switch box. So might be you delete all those VLAN, every time it going to increase the configuration reversion number. So no matter you have VLAN or not, once you connect, switch is going to compare, means you going to advertise VTP advertisement, switch is going to compare the configuration reversion number, and then devices find your configuration reversion number is higher than their local configuration reversion. So they are going to delete those VLAN from their database. So that thing we need to take care whenever we going to attach any switch to production network. Some of production network they not using VTP, so they using all their switches as a transparent mode because of some security reason as I discussed. So basically a configuration reversion number represent and synchronize VLAN database. So it increase every time whenever modification takes place, no matter you changing the name of VLAN, adding some new VLAN or deleting existing VLAN. So every time it going to increase. Server and client their updates their database if they receive higher configuration reversion number, no matter a configuration reversion telling there is no VLAN. So they will going to delete all those VLAN that they have exist as I take an example earlier. The range of configuration reversion number is from 0 to 65535. If you want to revert as a 0, you need to convert your switch as a VTP transparent mode. Either you can delete VLAN.dat file that is located on flags. So once you created any VLAN, it going to send trigger update out of every trunk port and will be sent across domain or across VTP domain, I should say. One more thing I would like to mention right there. Whenever you create any VLAN, that means you are going to create a broadcast domain, a instance of spanning tree and a MAC table. So these three things we create whenever we create any VLAN inside your switches. So these three things we need to understand. That is what the drawback about VTP version 1 and 2. We'll discuss later a little bit. And now VTP pruning. So VTP pruning basically block unnecessary traffic. Traffic could be unknown unicast, multicast or broadcast. But make sure if your switch running as a transparent mode, they are not going to turn on VTP pruning, since that is not applicable to them. VTP pruning we can perform auto and manual. So will better if we'll go through practical. So let me pause the recording and turn on my devices so that we can go through step by step of practical to understand these technologies. So alright, this is the topology that we're gonna to work with. Switch 1, switch 2, switch 3 and switch 4. Actually these are switch A, B, C and D. So let's verify whether it's already VTP is running. So I have created the alias so that efficient to execute the command. So all those switches, as we can see, switch A, switch B, C and D are working as a server. So let me execute some command to make little bit changes. First I would like to create interface trunk. So interface range gig 0/122 switch port mode, then trunk, and also would like to enable spanning tree or a rapid spanning tree for faster conversion or transition of port states. So spanning tree mode rapid, that's good. Let's see. So spanning, so interface trunk, hopefully we have the interface working as a trunk. So on switch 1, as we can see, gig 0, switch 2, there should be 2 ports that working as a trunk port. Yes, there it is. Switch C as well, and switch D should have a single. So far we find all those things that we expected. Now let me go ahead and enable these switches as a VTP. So what I decide work to keep this switch 2 as a server. This is going to work as a transparent. This is client and this is client. Okay, so this is switch A, VTP mode client. This is switch B, VTP mode server. C, VTP mode transparent. And last switch is VTP mode client. So let me execute command on switch B to enable VTP. So VTP, basically once we enable or we assign VTP domain name, that means we enabling VTP. So VTP domain name, let's see Aditya. So going to propagate out of every trunk port, and as we can see there is something went wrong. Check some mismatch even on this. So no issue. Interface range, let me flip the interfaces. Gig 1/2. Okay, interface range, excuse me, gig 0/122 shut, then after no shut. Hopefully now they are going to synchronize their MD hash. And now execute command show VTP status. Oh, again we getting the same problem. Just let me fix it. So now it's look better. Just I flip interface twice so that they synchronize themselves. Do show VTP status. So show VTP status, this is the alias I have created. Switch 1 is working as a client and join the domain, that is Aditya. Switch B working as a server, Aditya. Switch C supposed to be transparent and Aditya, and client as well. So that's good. So once we create VLAN, let's see, create VLAN on server, VLAN 2 and then name TWO2. One more VLAN, VLAN 3 and then after name 3. You can put anything. And let's see. Do show VLAN brief. Oh. Is there? No. So VLAN brief should we do because running on global. So we can see we have VLAN 2 and they're supposed to not any VLAN that propagate by the server, and we have 2. Oh, what about 3? I need to exit. I hope I can see now. VLAN 3 and there we go. So everything is fine now. What is problem when we using VTP version 1 and VTP version 2? Let me show you. What I am going to do, I am going to assign IP address on switch 1 VLAN 2, switch 2 VLAN 2, switch 3 VLAN 2. Since this is working as a transparent, so once we try to send out some packet out of this interface to VLAN 2 of switch 4, packet not going to work, means going to drop by switch 3, because switch 3 work as a VTP transparent mode that has not VLAN number 2 or VLAN number 3. That means there is no any forwarding instance, that means no spanning tree, no MAC table and no broadcast domain that is created by VTP for VLAN 2 and VLAN 3. So I am going to pause little bit video and assign the IP addresses. So I have assigned IP addresses to switch A, B and D. Let's execute command do show IP interface brief. On switch A we can see VLAN 2 is up, that's very good. VLAN on switch B VLAN 2 is up, good. In switch C there is no VLAN since this is working as a transparent, and let's see on switch D, that's good. So now this is time to check whether switch 2 able to send data to switch 4. So that's good. This is the IP address of switch D 10.10.2.4. So ping 10.10.2.4. let's see. We cannot get reply back because switch 3 has no instance of VLAN 3. There is no MAC table of VLAN 3 because of that. But once we want to ping out switch 1, this is working as a client, that we gonna work. So this is 1.2.1. There we go. But we cannot ping to switch 4. It doesn't mean if we assign IP address to switch 3 on VLAN 2 that going to work. Never. So let's see perform the practical. Interface VLAN 2 and then after IP address 10.10. This is 2.3 255.255.255.0. No shutdown. And go ahead and perform same task once again. We cannot. This is what the problem with VTP version 1 and VTP version 2. Great. One more thing that I would like to share with you. Let's see execute command on all those. So exit. So spanning tree for VLAN 2. Switch A, switch B as a root bridge for VLAN 2, and that not going to work on this transparent switch. And what about switch D? Switch D also telling to us I am also the root bridge for VLAN 2. Is this possible? Because of the problem with VTP version 1 and 2, it occur. So you need to know, you need to understand why this is. Actually, VLAN 2 is right there and right there. since this is working as a transparent mode, and I told you earlier there is no VLAN 2, so there is no instance of spanning tree of VLAN 2, there is no MAC table of VLAN 2, and there is no particular broadcast domain of VLAN 2, because this is the problem. Because of that we are not able to send out packet out of this way. So switch 1 consider themselves that I am the root bridge, since I am not getting reply back from anyone, and switch 2 become root bridge because of the lower MAC address. So this is two problems that we can see. And let me go through my book, or not my book, my documents I should say. So it not forward data that sent by another switches of any VLAN to other switches if transparent switch do not have same VLAN on local database that we see right there. If VTP domain do not match, they never send VTP updates to other. What I mean to say that, let's see, this is working as a VTP transparent mode, and the VTP domain name, since all switches has VTP domain name Aditya, let's see, this is transparent mode, and change the VTP domain name. VTP domain name, let's see, it's Aditya 22. So go ahead on server and create little one or two more VLAN, for instance VLAN 4, VLAN 5 and VLAN 6. So we means added 3 more VLAN. Let's see, do so VLAN brief, VLAN 4, VLAN 5, VLAN 6. We supposed to reflect on switch A, so VLAN, excuse me, brief, exactly, but we not supposed to see on switch D, so VLAN, excuse me, brief, because of problem with VTP version 1 and VTP version 2. So this is also problem occur if your VTP transparent mode switch working with different VTP domain name. And last and not least, third one, a trunk port that is connected to non-VTP supported switch. Just I need to skip this thing before we discuss about VTP pruning. So let's discuss little bit about VTP pruning, how we can perform manual pruning and automatic pruning. Excuse me. So now let me fix the problem. This is switch C, VTP mode, VTP domain Aditya. So that's good. Hopefully if we will flap the interface, they're going to send whatever VLAN created on server. So let's see VTP pruning. So exit out of every switches, excuse me, exit, and now execute the command. So VTP status, hopefully everything is fine. On switch configuration reversion number is 6, should be equal to B and equal to D. Oh, not get update now. Hopefully we'll get soon. It may take some time to get updates. And matching Aditya, right. Now what we looking to do? We looking to create or enable your switches to prune unnecessary traffic. What I mean by pruning unnecessary traffic, let me bring my notepad and then we're going to discuss. So suppose this is This is suppose also working as a transparent, and this may be server. And these three switches have VLAN 2, VLAN 3, VLAN 4. So 2, 3, 4, 2, 3, 4. And this switch last one is running VLAN let's see 5, 6 and 7. So if any broadcast message generated in VLAN 2 connected to switch 1, or any unknown unicast message or multicast message going to send out trunk port in corresponding or belong to same port, that VLAN 2. So sending out switch 2 going to send to entire VLAN ports along with out of this trunk port. So why switch required these unnecessary unknown unicast, multicast and broadcast messages from VLAN 2, 3 and 4? For this, to understand this better, we need to go through the documents. So let's see. So block unnecessary traffic. Traffic could be unicast, unknown unicast, multicast and broadcast. And suppose this is not capable when switch working as a transparent mode. How we can perform auto pruning? We need to enable only on VTP server. Rest of switches, they come to know automatically that VTP pruning is enabled. So they are going to send their let's see, switch C will tell to switch 3, hey, I have VLAN 5, VLAN 6, VLAN 7. So kindly don't send the unnecessary traffic that belong to VLAN 2, VLAN 3, VLAN 4, since I do not have those VLAN. So why are you sending those traffic to me? Similarly, suppose this one is working as a transparent. This is going to tell to the switch, hey, these are the VLAN that I have. Apart from this VLAN, please don't send any packet to me. So this is how your VTP pruning work. So let me enable. Execute on. First let me show you VTP pruning is not enabled yet. So we can see VTP pruning mode disabled. Similarly disabled and disabled. Go ahead on server and enable. So VTP pruning enable. So once we enable VTP pruning on server switch, they automatically going to propagate out of every trunk port, and rest of switches they will synchronize their settings, as we can see right there. But hopefully your yes, your transparent switch not going to apply that thing, disabled, but client should be exactly. So now let's see out of this interface which VLAN data are going to send and receive for VLAN pruning or VTP pruning. This is switch 2 or switch B. Execute a command. So interface pruning. So it's telling gig 0/1 and gig 0/2 VLAN prune for lack of request by neighbor. So this is switch B, and VLAN 3 to 6 are going to prune. You know why? Since switch 2, switch 1 and switch 4, there is VLAN 1 and VLAN 2 only are active VLAN, means assigned port. So obviously we have VLAN 3 and rest of VLAN, but we do not assign any port, or that VLAN is not active yet. So that's why we can see right there these traffic are going to prune. What traffic are allowed right now? From VLAN 1 to VLAN 2. So That's good. If suppose let's see, create this as a transparent mode, this switch work as a transparent mode. So configure terminal, VTP mode transparent, no VLAN 2, no VLAN 3, no VLAN 4, do so VLAN brief 5 and 4, 5 and 6. That's good. Now execute the same command to verify which ports I going to prune. Now we can see on gig 0/1, this one, excuse me, VLAN prune for lack of request by neighbor. So it's going to prune from 2 to 6 and going to allow only 1 to 2 because of there is only VLAN 1. Let me see. Yes. So 2 to 6 are pruned, only VLAN 1 is allowed. So traffic 1 allow, there should be VLAN 1 only, but will take some time to converge. So we can now understand VTP pruning. So sometime you can enable VTP pruning manually, since this is automatic. And when you need to enable VTP pruning manually, let's see, there is another scenario how I can complete this scenario. Switch 2, I am going to connect a port that goes to some other box, means this is not Cisco box, it could be a virtual server. Inside virtual server you can also create multiple VLAN, or it could be 3-com switch, suppose. So let me connect a cable. Alright, I have connected or cable on, this is actually F0/1. So go ahead and create this interface that is work like a trunk, switch port mode trunk. So actually, as per working of VTP will send VTP advertisement out of every trunk port in waiting to get reply back that which VTP are not going to prune. So since there is no Cisco device, they are not going to advertise that these VLAN I need to receive, the rest of all you need to block. So they are not going to send such message. That means by default switch 2 going to allow all those traffic out of this interface. But you may know there is VLAN 2, VLAN 3 and VLAN 4. On that time you required manual pruning to particular interface. Or you may have some other problem, because of that you are looking for, you want to keep block traffic for VLAN 2, VLAN 3 or VLAN 4 out of this interface. You can enable VTP pruning to particular interface. So better for you, go through the documents, I have mentioned all those things. Let me bring back. So auto pruning need to enable only VTP server, the rest of come to know automatically. And VLAN 2 to 1001 are illegible or prune illegible VLANs. This is true for VTP version 1 and VTP version 2. What I mean to say that if you have running extended VLAN version, that will not support. If you running VTP mode client or server, they are not going to prune at all until and unless you are using VTP version 3. So in VTP version 1 and 2, you cannot prune traffic from 1002 to 4094. In such situation you can use manual pruning. So it need to be created a allow list on trunk interface at any switches, no matter your switch is working as a client, transparent or a server. So manual pruning can be pruned in eligible and non-eligible VLAN. So that is good. VLAN 1 is also non-eligible VTP. VLAN. You cannot disable automatically. You need to execute command on particular interface to disable. So let's see how we can do this thing. So first, let me verify. So interface pruning. So we can see on F0/1 no one VLAN we are going to prune, no one. We are going to send every active, since we have two active VLAN, we are going to send every VLAN traffic out of this port. Since this guy, he never tell us which VLAN he looking for. That means he may looking for all, because of VTP is Cisco proprietary, and this box located right there is not aware about VTP. How does VTP work and how I need to respond back because of that. So that is very good. And let's see how we can enable that thing. So interface F0/1, this is the trunk port, goes to this box, and VLAN, excuse me, this is VLAN interface trunk, interface, switch port trunk, I think, switch port trunk, and then after what, allowed, and what VLAN you want to allow. Let's see, if you know already which VLAN you need to send out of this interface, you can enable on it. So hopefully this thing you know very well. I don't need to go to line by line. So for instance, let's see, allow VLAN to only, and now execute the command. Do so VTP, and then after prune, sorry, interface, excuse me. So interface, now we can see right there, we are only going to send VLAN 2 updates, and these are pruned because of neighbor never sent to us. But make sure this thing we have applied manually. So I think we have covered up all the objective of this video, and let me check whether we have left something. So we have discussed detail, modes, and authentication we left. So let me apply VTP authentication. So VTP, then password, and let's see Cisco. I need to apply all those switches, suppose. So exit, configure VTP password Cisco. So that's good. So now how we can see the VTP password? We need to execute command do so VTP password. So now we can see this is the Cisco. So hopefully so far we have discussed all those things that I have mentioned in these documents. In upcoming video we will discuss for VTP version 3. So would like to say thanks for watching.